Okay, today we are going to do 10.7 polar coordinates. So this is just a different way to look at how we graph. Of course, in the rectangular coordinate system, we have a point x, y. So say you had the point 4, 5. All right, for the point 4, 5, you know you go over 4 and up 5. And then, woo, there's our point. All right, so we're going to define a different way to get to a point. Instead of over and up, we're going to do angle and radius. Okay, so what we do is we start with a fixed point that is called the pole, and then we make the x-axis, this ray, is called the polar axis. And then we take any point on here we can find by saying what angle does it make with the polar axis, and then what direction and length do we go. So, for example, let's say I wanted to do the point that has an angle of pi over 3 and a radius of 2. Okay, then I would look at the angle pi over 3 right here, and I would go, oh, out 2 units, a radius of 2. So that would be the point 2 pi over 3. Now the fun thing is that you can also do these in negative directions. So if I wanted to do the point negative 2 pi over 3, that basically tells me I'll go backwards. So where this one went forwards, negative 2 pi over 3 will go backwards and will actually be in the third quadrant instead of in the first quadrant. Okay? You can also do negative angles, just like we've graphed negative angles in the past. All right, so here's your turn. Plot the point negative 2, 7 pi over 4. And now I'll do it. So it's 7 pi over 4, which will be here. And then negative 2, so I'll go backwards. So it's actually here in the second quadrant. Okay? Now, of course, because we can get to these places many, many different ways, we don't have a unique representation for a point. We can get there lots and lots of ways. So, the other three other representations for 4 pi over 6. So first, let's start by graphing 4 pi over 6. Okay, I'll let you do it. And pi over 6 and 4 would be right there. All right, now come up with 3 other ways using negatives and positives for a radius and angle. And pause here, and you come up with those. And now that's what we got. So let's see, if I were to go negative 4, I would need the angle over here. And that would be 7 pi over 6. Or negative 4, and if I made the angle negative, that would be negative 5 pi over 6. Or if I use a negative angle and a positive 4, and then I would have to come all the way around like this, and that angle would be negative 11 pi over 6. So those are 3 different representations for the point 4 pi over 6. All right, so how do we convert How do we take a rectangular coordinate and make it polar? Well, let's look at a rectangular coordinate. We'll call it xy. So x represents what as far as the angle goes? Cosine of the angle times r. Because the cosine of the angle is x over r. And then y would be r sine of the angle, theta. And if we look at angle theta, what would be the tangent of theta? I think you can see in the triangle, that would be y over x. And then what would r squared, if this is r, what would be r squared? I believe if we look at the Pythagorean theorem, that would be x squared plus y squared. All right, so these are the 4 equations we're going to use to convert. So you're going to have to know those 4 equations. And they're not that bad. They all relate back to the triangle. All right. So convert polar coordinates 3 pi over 2 to rectangular coordinates. And pause here and try that. So x is 3 cosine 3 pi over 2, and y is 3 sine 3 pi over 2. So the cosine of 3 pi over 2 is 0, and the sine of 3 pi over 2 is negative 1. So 0, negative 3 is the xy coordinate. And then now try for the polar coordinate. For the xy point, 5, 5. All right, so you have to find the r and the theta. Oh, wait. No. So tangent of theta equals 5 over 5. So that would be 1. That's in the first quadrant. You have to think about quadrants again. So that angle is pi over 4. And then how are we going to get r? Well, r squared equals 5 squared plus 5 squared. So r equals 5 square root of 2, or the square root of 50. So our coordinates are 5 square root of 2 pi over 4. All right. Now, using the same equations, we're going to convert a rectangular equation to polar form. So I want you to plug in for y and x and simplify. And I'll stop and wait, pause it. R sine theta equals r squared cosine squared theta. All right, and so r sine theta over cosine squared theta is r squared. And then yes, you are allowed to divide by r. So r equals sine over cosine, which is tangent theta, and then 1 over cosine, which is secant theta. Okay? That's how you make a parabola in polar form. All right. Now our last one is going to be just changing from r to x and y. So remember what we need for x and y. We're going to need some cosines and sines. So our first one here, r equals 5, doesn't fit the cosine or the sine. But what we can do is look at, it almost fits the r squared equation. So let's square it. R squared equals 25. And we can replace r squared with x squared plus y squared equals 25. And so I think you'll see that r equals 5 is a circle of radius 5. And then r equals cosecant of theta. So let's see, that's r equals 1 over sine of theta. Or r sine of theta equals 1. And r sine of theta is y. All right, so we can square the r if we have a nice number that makes sense. If you have a trig function, see if you can get it to r sine or r cosine, and then it is a nice substitution. All right, well, there is working with polars.